Alright guys, in this video I am going to be going over the first problem from your homework that's due on Monday. Right, due Monday at 9 o'clock. So your homework is like 3 pages, so I'm doing a third of it for you guys. So everyone should be getting this correct, assuming you're watching this video. It's a problem we've done before, but I want to incorporate some of the new ideas from this graphic organizer. So if you haven't already watched the lesson and completed this part, please complete this first. Alright, so this is very similar problems to problems we've done before, right? We've done throwing a ball in the air and then it hits the ground. But what we haven't done is written it in vertex form before. Well, not specifically a problem like this, right? But we should be able to get this in vertex form. So let's take a look. An object launched upward at 64 feet per second from a platform 60 feet high has a height that can be modeled by this equation. Alright, and by the way, if you guys are wondering why we always see this negative 16 in front of the t squared, right, that comes from physics because the acceleration due to gravity is 16 feet per second squared towards the center of the Earth. So that's why it shows up in the equation. So anyway, writing this in vertex form, h of t equals negative 16 t squared plus 64 t plus 60, right? So the first step is to move the constant, right, which is the 60, to the other side. So I'm going to minus 60 from both sides, and I'll get h of t minus 60 equals that. Right? Before we can complete the square now, right, whenever we complete the square, this a value has to be equal to 1. Right? So what you do is you factor out that negative 16. So I have negative 16 times t squared. What is 64 divided by negative 16? That's negative 4t. And over here, that's still h of t minus 60. I don't know why I switched colors. I'm going to make this pink again. Right, and now I can complete the square. So inside this parenthesis here, what do I need to add to complete the square? Well, it's always half of this middle value squared. So half of negative 4 is 2. Or negative 2, and negative 2 squared is positive 4. So I'm going to be adding 4 to both sides. But wait, am I really adding a 4 here? Right, what I'm really adding is negative 16 times 4. So over here, this should be minus 64 here. Right, so on the left side now, I have h of t minus 124 equals negative 16 times, in parentheses, t minus 2 squared. And adding 124 to both sides, I have h of t equals negative 16 times t minus 2 squared plus 124. So that is my equation in vertex form. So now that I have it in vertex form, even though it doesn't ask for it, can't I find the vertex? Right, our vertex is going to be, remember this is our horizontal shift, right? That's 2 to the right, it's opposite, right? And that is 124 units up. So my vertex is going to be at 2, 124. So what will the object's maximum height be, and when is it going to attain this height? So we actually already answered this question right here with that. Right, because if we think about what this is going to look like when we graph it, I'm going to skip down to letter D here, right, which says make a sketch. Well, I already know my vertex is at 2, 124. So 2, 124. Let's say it's right there. Well, if this is our parabola, something like this, right, I'm going to erase it, but draw it back later. That's our parabola. Isn't this our max height, right? That 124, that y value, right, not really our y value, but our h of t value, that's the height. That's our max height of 124. And when does this happen? Well, the x coordinate was 2, right? And isn't our x-axis here represent t, or the time? So at time 2, we have a maximum height of 124. So this 2 here, this represents when it reaches the max height. So after 2 seconds, right, the max height is 124 feet. This is our max height. So when will it attain this height? I can answer that with after 2 seconds or at t equals 2 seconds. All right. So another way to answer letter B, right, is to get the vertex again. But don't we have another way of getting the vertex now? Right? Another way to get the axis of symmetry is x equals negative b over 2a. Right? And the axis of symmetry, that is the x value of the vertex. Whoops. Right? Because our axis of symmetry, right, it's going to be right there. And our vertex, again, is always on the axis of symmetry. So all I have to do is plug in the axis of symmetry to get the max height. So let's pretend letter A wasn't here and you didn't have to get vertex form. If you just had letter B and you wanted to answer this question, you could also do x equals negative b over 2a to get the axis of symmetry. And let's see what that equals. So our b value is 64 and the a value here is negative 16. So we also could have done negative b value is 64, right? And our a value is negative 16, so 2 times negative 16. That's going to give me negative 64 over negative 32, which is 2. So what we found was the x-coordinate of our vertex, right? 2. So that's another way to get when it's going to reach its max height. And to get the actual max height, once you have this 2 value, right, we could plug it in. Because we know the max height is reached at time equal 2. So all we have to do is plug in a 2 into this equation to get the height after 2 seconds. So if we do that, that's going to be h of 2 equals negative 16 times 2 squared. What was it? Plus 64 times 2 plus 60 times 2. Right? And if we work this out real quick, order of operations, make sure you're squaring first. That'll be negative 16 times 4 plus 128 plus 120. All right, negative 16 times 4 is negative 64. And adding these numbers together, right, I'm just going to copy the answer. We should be getting 124 feet. Wait, I think I messed up somewhere. Why did I multiply this last guy by 2? That should just be a 60. Right? And so adding those numbers together, we should be getting 124. So after 2 seconds, our max height is 124 feet. Right? Just another way of doing it if you didn't want to get into vertex form. Right? But obviously over here you had to get in vertex form. That was a question. All right, letter C. Assuming the object falls past the platform, after how many seconds will it hit the ground? Round to the nearest tenth of a second. All right, so the scenario here is we have this object that's on some platform. Right? It's been drawn up, it's going to come down, but it's going to miss the platform on the way down, it's going to hit the ground here. So when is it going to hit the ground? After how many seconds? Whenever we have this question, when does it hit the ground? That is talking about the zeros or the x-intercepts, because when something hits the ground, that's when the height is 0, right? When something hits the ground, the height is 0, which means h of t is equal to 0, which means we're looking for the x-intercepts or the roots or the zeros. So we make the height there 0 and we solve the equation. So 0 equals negative 16t squared plus 64t plus 60. All right, so we've done all of this before, right? Just the equation's a little different, but I'll let you know this equation here is not factorable, so we need one of our new strategies here to solve this equation. Right? If you try to factor this real quick, try to take out a GCF or you try the AC method right away. If I do AC method, I think I can factor out a negative 4t squared. That's going to be minus 16t. 60 divided by negative 4 is negative 15. Right? I can tell you that there's nothing that multiplies to, if I use AC method, 4 times negative 15, that's negative 60. There's nothing that multiplies to negative 60 and adds to negative 16. Right? You might think negative 10 and negative 6, but that multiplies to positive 60. So it's not factorable, and a hint is that it says round to the nearest tenth of a second. Right? If it's telling you to round your answer, it means you're going to get a decimal answer, which means it's probably not going to be nice numbers that you can get by factoring. So what I'm going to do instead is solve it using, well, one of my other two methods. So this one, like we just talked about, was not factorable. Not every quadratic is factorable, but we still have two other methods left over, which are completing the square and quadratic formula. So, no, I keep doing that. So, we already pretty much did completing the square here, right? When we solve it by completing the square, it's going to be very similar. So, I think I'm going to use quadratic formula this time. Quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So x equals, our b value here is 64. That's negative 64 divided by 2. My a value is negative 16. So 2 times negative 16. Plus or minus the square root of, alright, our b value is 64. So that's 64 squared. The numbers are going to be huge here, so you got to be really careful. And definitely type everything into your calculator. Minus 4, the a value is negative 16 times c is 60 divided by 2 times the a value again is negative 16. So simplifying this a little, we are going to get negative 64 over negative 32 plus or minus the square root of 64 squared is 4,096. 4 times 16, that's going to be 64. 64 times 60, that is going to be 3,840. And it's going to be positive because two negatives, right, make a positive when multiplied, divided by negative 32. So x equals 2 plus or minus the square root of 7,936 divided by negative 32. All right, that's kind of crazy. Yeah, I would not expect you to write this in simplest radical form. So all we're going to do, or all I'm going to do, is take all this and type that into the calculator. Right? And again, that's two solutions. That is x equals 2 plus, let me just copy and paste. That's x equals 2 plus all of that, and x equals 2 minus all of that. So take that, and we're going to do x equals this, plus that quantity, and we're going to do x equals negative 2 minus that quantity. And why do I have a negative? It should be positive 2, right? Yeah, that was a positive 2. So, again, this 2 here, that was our axis of symmetry, right? This is this 2. So, this crazy guy, this square root of 7936 divided by negative 2, that's the distance to get to our two zeros. right? Because we're just adding and subtracting that from 2, which is pretty cool. So if we take a look, why is it? All right. Typing this into your calculator, we should be getting around negative 0.784. And typing this into our calculator, we should be getting around 4.784, something, something, something. So assuming the object falls past the platform, after how many seconds is it going to hit the ground? Right, we're going to ignore the negative answer because it's not going to be negative time. It's going to be after about 4.8 seconds. And there we go. Also, technically, when I solve this equation, it should not be x equals, it should be t equals, right? Because the t was the variable in my equation. So you should change all those x's to t's, but after 4.8 seconds. So if I'm drawing this to scale now, or at least a little bit more to scale, let me actually stretch this out a little. I'll make 2 over there, 1 over here. All right, that looks good. All right, 3, 4, and 5. I know it hits the ground after 4.8 seconds approximately, so I can put a 0 here. And I also know that my other 0 is at negative 0.8, right? But that's not part of the domain because I'm going to start at time 0 whenever I'm doing one of these kinds of problems. And it started at a platform that was 60 feet high. That's over there. That's going to be the y-intercept. If you plug in a 0 for t, right, the initial height is at time 0, you're going to get 60. So I'm going to say 60 is somewhere over here. That's going to be our starting point. After 2 seconds, it reaches a max height of 124. And after 4.8 seconds, that is when it hits the ground. And these are really the points we need for our sketch: vertex, y-intercept, and zeros. In this case, I only did 1 0 because it said graph it over the appropriate domain. All right, so I hope this helped. This is really the basis of everything we've done for quite a while. So make sure you can do all the stuff in here and make sure all of this makes sense. All right. So that's going to be it for today. I'll see you guys next time. Finish the rest of this up for homework. And as always, if you have any questions, let me know. All right.